Hi students, in the previous class we discussed about time shifting. Time shifting. So after that we have amplitude shifting, time scaling, amplitude scaling and time reversal from operations on signals. Okay. So in the topic operations on signals. In the topic operations on signal, in the previous class I covered time shifting operation. Time shifting operation. Now I'm going to explain you the operation of amplitude shifting. Amplitude shifting. So today's topic is amplitude shifting. Okay, amplitude shifting. So for the last two classes I'm explaining you about the topics operations on signals. Operations on signals. So first I perform addition, subtraction and multiplication operations on two signals with respect to the parameter amplitude. Here in the last class I explained you time shifting operation with respect to the parameter time. Now here I am explaining amplitude shifting operation with respect to the parameter amplitude. With respect to the parameter amplitude. Okay. Now while performing the operations with respect to the parameter amplitude, only the amplitude will vary and the time will remain constant. You all know that. So now let us consider a signal x of t. For that, let us consider a signal x of t. Now you have to perform amplitude shifting operation on the signal x of t. On the signal x of t, you have to perform the operation amplitude shifting. That is, on x of t, if I perform amplitude shifting, it will produce a result y of t which is equal to x of t plus x of t plus some constant. Let's take I'm taking capital M. You can take anything. So while going for the time shifting, I had taken small m. Here I had taken capital M. You can take a small m here also, whatever it may be. Okay, so this is some value. Let's take 5, 10, minus 0, 0.5, 2, 2.5, whatever it may be. It has some value. Okay. Now, here in amplitude shifting, if you perform the operation on x of t, the amplitude shifted version of the signal is nothing but x of t plus m. X of t plus m. Okay. Now, this is the amplitude shifted version of the signal x of t. Okay. Now, if I want to explain this, I will use the waveforms. So, diagrammatic explanation is well suited for these operations on the signals. For your better understanding, I will take diagrammatic representations. Okay, so I will take some waveforms and I will explain the concept of these amplitude shifting with respect to that waveform. Okay, simple. For that, I am taking x of t as this is t and this is x of t. This is t and this is x of t. Let's take the signal may be like this. This is 1 and this is 2. This is 1 and this is 2. Okay. There is a signal like this. Now I want to perform amplitude shifting operation on this signal. Okay. If I perform amplitude shifting operation, then that can be expressed as x of t plus M. Now, here the shifting will depend on this capital M, and the value of that capital M. On the value of this capital M, the shifting of the signal will depend. Okay, so for this, if consider if that M value is greater than 0, M value is greater than 0. Consider if M value is greater than 0. It is greater than 0. Okay. And what happens? Then the signal will move upwards. Move upwards. So that type of shifting is called as upward shifting. Upward shifting. So that produces upward shifting. Okay. If M value is less than 0, M value is less than 0, that is negative, minus 5, minus 10, minus 15, that will produce, that will move, shift, that is will move the signal downwards. Downwards. So, downward shifting. Downward shifting. See, simple logic. If the variable M, the value of M is positive, that is greater than 0, then the signal will move upward. Hence, it is called as upward shifting. If the value of this M is negative, that is less than 0, then the signal will move downward. Hence, it is nothing but downward shifting. Now, we will see how the signal will move upward or how the signal will move downward. Simple logic, shifting, moving. So, amplitude shifting. So, the signal will move with respect to the amplitude. Here, I have taken the amplitude on y-axis, that is vertical. Hence, the movement is along the vertical axis. That is, the movement is either upward or downward. Whereas, in time shifting, the shifting means moving of the signal. Here, the shifting is with respect to time. That is, moving is with respect to time. There, the time is on x-axis. Time is on x-axis. So, the signal either will move right side or left side. Hence, there in time shifting, I got positive shifting and negative shifting. Whereas here in amplitude shifting, here I'm taking amplitude on y-axis. So here the signal will move either upwards or downwards. Hence, we have upward shifting and downward shifting. How this shifting will occur? Now we will see. How this shifting will occur? Now we will see. For that, I have to consider the value of this M. Let us take M will be equal to some 2. Let consider the M value will be equal to 2. This is our signal. This is our signal. Now M value is 2. So now I have to draw the signal. X of t plus 2. X of t plus 2 is the amplitude shifting version of the signal x of t. Okay. Now first thing, there is signal x of t. Now I perform the operation of amplitude shifting on the x of t. Then it will produce an output y of t, which is equal to x of t plus some value. Okay. That I had treated as capital M. You can take that as your wish. Here I have taken as capital M. Now, so the amplitude shifting operation on signal x of t can be expressed as x of t plus capital M. If the capital M value is positive, that is greater than 0, then the signal will move upward. It shifts upward. Hence, it is called as upward shifting. If the value of M is less than 0, that is, the value of M is negative, then the signal will move downward. Then it is called as a downward shifting. Okay. So to explain this upward shifting and downward shifting, I am considering value of capital M as a positive value, that is greater than 0. First, I have taken a value of M equal to 2, which is greater than 0, which is a positive value. Now, the amplitude shifting version of x of t can be written as x of t plus 2. Now, I have to draw the waveform for x of t plus 2. I have to draw the waveform for x of t plus 2. How I will draw that signal? See, here First, I have to consider t, and on x-axis I have to go for x of t plus 2. I have to draw this waveform. How will you draw? So for that, I have to consider a signal. Based on this diagrammatic representation, how can you go for the equation of this signal? Equation representation of the signal. See, on seeing this diagram, I can write the equation as for the input signal x of t. X of t will be equal to 0, 0. This is 0, 0 for t less than 0, 0 for t less than 0. If the value of t is less than 0, that is minus 1, minus 2, minus 3, there is no amplitude, there is no values of x of t. Hence, x of t equal to 0, 0 for t less than 0. In the same way, x of t equal to 2 for t equal to 1, t equal to 2 and t equal to 0. That is, the t value is between 0 and 1, 0 and 1, and between 1 and 2, and between 1 and 2, the amplitude of the signal is 2. That is, the t value is between 0 and 2. The value of x of t is 2. The value of x of t is 2. So how can you write the value of x of t is 2 for t between 0 and 2, that is 0 less than or equal to t less than or equal to 2, that is t is equal to 0 or greater than 0 and t is equal to and less than 2. So between this 0 and 2, the value of x of t is 2. The last one, greater than 2. The value of t is greater than 2. So 3, 4, 5. For 3, 4, 5, what is the value of x of t? X of t is 0. There is no signal. So again it is 0 for t greater than 2. Greater than 2. So it is 2.5, 3, 3.5, whatever it may be. Okay. Now, see. So this is the representation of this waveform. Okay. Equational representation of this diagrammatic representation. Simple. So I represent in the form of an equation. Simple. Okay. Now based on this, I need the amplitude shifted version. So the amplitude shifted version is nothing but x of t plus 2. X of t plus 2. How will you get that x of t plus 2? Simple. X of t plus 2. Okay. These are actual outputs. Actual output y of t. Simply this is our y of t, which is equal to x of t plus 2. Now see, I need the equation for this y of t or x of t plus 2. How can you get? For t less than 0. T less than 0. Because as I am performing amplitude shifting, the variation is only with respect to amplitude and there will be no variation with respect to time. So we can consider the time constant as it is, that t is less than 0. T is less than 0 and 0 less than or equal to t less than or equal to 2 and t greater than 2. There will be no change in this one. Simply write for t less than 0. For t less than 0, the signal is that output y of t is x of t plus 2. What is x of t for t less than 0? 0. So it will be 0 plus 2. 0 plus 2 is 2. So for t less than 0, the value of x of t plus 2, that's shifted version. Okay, amplitude shifted version. Y of t is x of t plus 2, that is 2. Next, between 0 less than or equal to t less than or equal to 2. 0 less than or equal to t less than or equal to 2. In this, actual x of t is 2. Now x of t plus 2, that is 2 plus 2, that is 4. And in the third case, for t greater than 2, x of t is 0. X of t is 0. Now x of t plus 2, 0 plus 2, again it will be 2 for t greater than 0. So I got the equation representation of x of t plus 2. For this equation representation, I have to draw the waveform. Simple. So after seeing this, you can draw the waveform. See, for t less than 0, the value is 2. Let us take this is 0, this is 1, this is 2, 1, 2, 3, 4. Okay. So t less than 0, t less than 0, the value is 2. So 2 is this one. So for all the values of this one, that is 2. Okay. So t less than 0, that value is simply 2. Okay. 2. Between 0 and 2, that is t value is equal to or greater than 0 and equal to or less than 2. Between 0 and 2 of the t value, the value of x of t plus 2 is 4. Amplitude shift version is 4. There is 4 from 0 to 2. 0 to 2. It is 4. Again, t greater than 2. Again, t greater than 2. The value is again 2. So after 2, the value of t after 2. So the value of t is greater than 2. Then the amplitude shift version x of t plus 2 is equal to 0 plus 2. That is 2. So here we have to stop. And here we have to draw like this. T greater than 2, that is 3, 4, 5 and so on. The value of x of t plus 2 is nothing but x of t is 0 in this case. So 0 plus 2 is 2. So that will be equal to 2. Here the point. So from here onwards, it goes on with 2. So see, actually this is the signal. If you observe clearly, this is the signal, input signal. Now the shape of that input signal is moved upwards. The same shape is moved upwards. So in the direction of a y-axis, that is vertical direction, moved upwards. Hence this type of shifting is called as upward shifting. Okay, are you clear? So this is nothing but upward shifting, as the waveform has shifted upwards in the amplitude direction, that is in the y-axis, in the direction of y-axis. So positive y-axis, in the direction of positive y-axis, and it is called as upward direction. Okay. Now next one is downward direction. The downward direction. How will you get the downward direction? That is downward shifting. How will you get the downward shifting? Simply by taking the value of that m less than 0, that is negative. Let us say, if in the next case, let's consider m equal to minus 2. So here the value of m is less than 0, that is negative, minus 2. Now the amplitude shifting expression for this x of t will be expressed as x of t minus 2. Clear? X of t minus 2. Now I have to draw the signal for this x of t minus 2, because this is the amplitude shifted version of the signal x of t. Because here I had taken the capital M value as minus 2. Okay. Now how will you draw? The same procedure. Here also I go for same procedure. See, here I am writing the diagram. The same procedure you can apply. Okay. Now 1, 2, simply 1, 2. If downwards, this is minus 1, minus 2. So this is minus 1, minus 2, like this. Okay. Now see, this is t, and this waveform is x of t minus 2. I have to draw x of t minus 2. Okay. So this is the amplitude shifted version of x of t. How can I draw this? Simple. Again, use this equation of representations. So I am showing this here. See, I am showing this here. Okay. Now the amplitude shifted version, that y of t is equal to, here the y of t, in this case our y of t equal to x of t minus 2, because this m value is negative, x of t minus 2. Okay. Now for this I need the equation. So I need the equation for x of t minus 2, which will be equal to, now this also, the shifting is with respect to amplitude, there is no change with respect to time, hence I have to take the time variation same, that is at t, this t is less than 0, that is t is less than 0 and 0 less than or equal to t less than or equal to 2 and t greater than 2. Okay. Now x of t minus 2, simple, for t less than 0, for t less than 0, what is the value of x of t minus 2? So for t less than 0, x of t is 0, 0 minus 2, 0 minus 2 is minus 2, 0 minus 2 is minus 2, okay, 0 minus 2 minus. Between 0 and 2, if the value of t is between 0 and 2, what is the x of t? X of t is 2. Now here x of t minus 2, that is 2 minus 2, which is equal to 0. In that case, t greater than 2. For t greater than 2, x of t is 0. So for here, 0 minus 2, 0 minus 2, nothing but minus 2. So the values are like this. Okay. For t less than 0, the value of x of t minus 2 is minus 2. For if the t value is between 0 and 2, the value of x of t minus 2 is 0. If the t value is greater than 2, the value of x of t minus 2 is minus 2. Now you can draw this waveform for these equations. By seeing this equation, you can draw the waveform. So how can you draw the waveform? For t less than 0, that is this is minus 1, minus 2, minus 3. The value of x of t minus 2, the value of x of t minus 2, the value of x of t minus 2 is minus 2. So for all these values, it is minus 2. So where is minus 2? Here is a minus 2. Draw the line like this, minus 2. So for minus 1, minus 2, minus 3, minus 4, whatever it may be, the value is minus 2. After that, between 0 to 2, if the value of t is between 0 to 2, what is the value? 0. That is, the value of t is between 0 and 2, the value of x of t minus t is 0. That is 0. 0. I hope you are clear with now. I am using a different one. Okay, 0. And next, after t greater than 2, the value is again minus 2. Greater than 2, that is 3, 4, 5. 3, 4, 5. For this, the value is minus 2. Minus 2 is here. So for t greater than 2, like this. After this is again minus 2. This is again minus 2. See, this is a waveform. This is a waveform of amplitude shifted version of the given signal x of t. So this is the given signal. For this is the amplitude shifted version. If m value is negative, if m value is minus 2, m value is minus 2. See, here the shape is like this. Here the shape is like this. Okay. Now the same shape has moved downwards. The same shape has moved downwards. Hence, this type of shifting is called as downward shifting. This type of shifting is called as downward shifting. Okay, simple logic. So here see the same waveform. This is a given signal. This is the shape. The same shape has been moved upwards. Moved upwards. Okay. Here the same shape is moved downwards. Hence, this is the upward shifting and this is the downward shifting. So this is the amplitude shifting of a continuous time signal x of t. So in continuous time signal x of t, we have two types of shiftings, upward shifting and downward shifting. Okay, now you have to do the amplitude shifting for discrete time signal, that is x of n. The concept is same for discrete time signal also. So in place of continuous time signal, you can take a discrete time signal. You can take a discrete time signal. So you can take any example. For this, perform the upward and downward shifting. Okay, upward and downward shifting. So I left that for your practice. So in yesterday's class also, I explained time shifting with respect to continuous time signal, and for your practice, I left time shifting operation with respect to discrete time signal. Here also I explained amplitude shifting with respect to continuous time signal, and you have to do the amplitude shifting with respect to discrete time signal. Okay, I hope you are all clear with this amplitude shifting. Next, we will go for time scaling. Now we will perform time scaling operation. So I completed time shifting and amplitude shifting. Now I will explain you time scaling operation. See, time scaling, the name itself tells you that the scaling is with respect to time. So the variation is with respect to time only, and there will be no variation with respect to amplitude. So there will be no variations, no changes with respect to amplitude. Only the changes or variations will occur with respect to time. Hence, we are performing time scaling operation. The scaling is with respect to time. First thing. Now, if you perform the time scaling operation on a signal x of t, if you perform time scaling operation on a signal x of t, okay, that can be expressed as the time scaling operation on a signal x of t can be expressed as x of small a into t, or simply if you perform time scaling operation on this x of t, that will produce an output y of t, which is equal to x of at. Simply you can write like this. So which will be equal to x of at. So here my signal is x of t, and I am performing this time scaling operation on that signal x of t. So it will produce an output y of t whose value will be equal to x of at. That is, a time scaling operation on the signal x of t can be expressed as x of small a into t. See, here I have taken the value of small a. So you can take anything. So in some textbook they will use alpha. So here I have used small a. It's up to you. You can use anything here. Okay, any variable here. So now, based on the value of this a, we have two variations in the time scaling. That is time expansion or time compression. That is, the time scaling operation will result in expansion or compression of the signal in time. That means the time scaling operation will result in either time expansion or time compression. So the time scaling operation will result in this time scaling operation will result in time compression or time expansion. Okay, so this time scaling operation will give you either time compression or time expansion. Okay, so now how the time will be compressed, how the time compression will perform, and how the time expansion will take place. So we have to see how these will take place and these will take. Now these two are dependent on the value of that a, the value of that a. In general, the a value is always positive. In general, the value of the small a is always positive. The value of a is always positive. Okay, first thing. Now here simply by considering the value, if by considering the value of a, that is if mod of a, I had considered mod, it is minus a also plus a, that is if mod a is greater than 1, mod a is greater than 1. Actually, if you want to say perfectly, that is from minus infinity to minus 1 and 1 to infinity. So these are the range. That means there is no values between minus 1 to plus 1. So that is the exact meaning of this one. Simply if a is positive, mod a is greater than 1. Mod a is greater than 1, then the signal will be compressed with respect to time. Signal will be compressed with respect to time. Then we get time. Then we get time compression. Then we get time compression. Okay. Next, if the mod a value is less than 1, the mod a value is less than 1, that means less than mod a, that means minus a plus a, that is minus 1 to plus 1, that is minus 1 to 0 and 0 to plus 1. Okay, if you actually say this is 0 to 1, in general we will take as 0 0.2, 0 0.5, 0 0.9, everything 0 0.2, 0 0.5, 0 0.9. If value is less than 1, then there takes place the time expansion. Then time expansion will receive it. Is the signal will be expanded with respect to time. The signal will be expanded with respect to time. Okay, so these are the two things that will occur in time scaling. Simple. How can you get the time scaling? How can you get the time scaling operation on the signal? Simply just by replacing the variable t with at. Simply by replacing, as the given signal is x of t, as the given signal is x of t. Now how can I get the time scaling expression? Simply the time scaling operation of x of t can be expressed as x of at. How can I get? I replace t with at. Simply replacing the variable t with a into t. A into t. Simple. Okay, remember this thing. So the time scaling will perform just by simply replacing the time variable small t with a into t, and based on the value of that a, we have two types of that is time compression and time expansion of the signal. So based on the value of a, we have time compression of the signal or time expansion of the signal. In general, a is always positive. If mod a is greater than 1, then the time scaling operation will result in time compression. If a mod a value is less than 1, that is like 0.5, 0.6 like that, then the time scaling operation will result in time expansion. So this is the theory about this time scaling. Now I have to show you diagrammatic representations for your better understanding. Simple. So this topic also will be, I already told you, these operations on the signals I will explain with respect to diagrams, with respect to waveforms. So the explanation with respect to waveforms will give a clear idea about what the operations are. So for that reason, I am explaining the time scaling also with respect to the waveforms. Okay, So first I have to consider a waveform for the signal x of t. I have to consider a waveform for signal x of t. So for x of t, I am consider. Let us consider the signal x of t as. So how will take the signal x of t? We take any type of signal. See, here also I am explaining with respect to continuous time signal. X of t is the continuous time signal. So I am explaining the time scaling with respect to continuous time signal. Observe very carefully because we have to do the same time scaling operation for discrete time signal. That is for x of n, you have to do this time scaling. Simple. Okay. First observe this. The explanation is same for discrete time signal also. Only the change is here the small t is replaced with small n. Here the signal will occur continuously. There the signal will occur at time instance n equal to 1, n equal to 2, n equal to 3. Okay. So for 1, 2, 3, 4, minus 1, minus 2, minus 3. In these cases only the time signal will occur. Okay. So first I am coming to the continuous time signal. Now I am going for time scaling operation on the continuous time signal. So for that reason I am considering an example. Okay. Considering an example. See how I will take the example. Let us consider the waveform like this. The waveform like this. Simple example. The previous example is simple example. 0, 1, 2, 1, 2. Simple. For this, I have to go for time scaling. Here, time scaling will result in either time compression or time expansion. First, I will consider the value of this a greater than 1. Value of this a greater than 1. Greater than 1. Okay, clear. Greater than 1. Greater than 1 means we can take any value. 2, 3, 4, whatever it may be. So far, here I am considering the value of a. The value of a equal to 2. A equal to 2, which is a positive value which is greater than 1. Is greater than 1. A equal to 2. I am considering a equal to 2. Okay. Now I have to go for the scaling, time scaling operation. That means I have to get the signal for x of 2t because a value is 2. So I have to get the signal for x of 2t. How can I get that one? Simple. See here. So this is t and this is x of t. Now I have to get signal for which one? This is t and this is x of 2t. X of 2t. Simple. Y of t equal to x of at. Now for this, see, we know the time scaling operation on x of t will give y of t, which is equal to x of 80. X of 80. In our example, the value of a I had taken as 2. So I have to written as x of 2t. X of 2t. Okay. Now see, if t value equal to 0, if t value equal to 0, what happens? If t equal to 0, y of 0 equal to x of 2 into 0. X of 2 into 0 is 2 into 0. That is x of 0. Next case, t equal to 1, y of 1 will be equal to x of 2 into 1. 2 into 1, simply x of 2. Simply x of 2. Next, y of 2 for t equal to 2, y of 2 equal to x of 2 into 2, that equal to x of 4. X of 4. Okay. Now see, here I have the values of x of 0, I have the value of x of 1, I have the value of x of 2, and x of 3, x of 4, x of 5, the values are zeros. The values are 0 because this is t equal to 0. The x of 0 equal to this one, x of 1 equal to this one, x of 2 equal to this one, x of 3. So x of 3 is 0. There is no value of that one. So simply see, what is the value of x of 0? X of 0 value is the value of x of 0, and the x of 0 value, that is 2. That is 2. What is the x of value of 2? This is x of 2. X of 2 is again 2. X of 2 is 2. And what is the value of x x of 4. What is the value of x of 4? X of 4, there is no amplitude. X of 4, there is no amplitude, that is 0. So x of 6, x of 8, everything is 0. So there is no need to consider these things because they are zeros. So we will go up to these two. These two. Simple. That is, now I have to draw the waveform for x of 2t. Actually, what is this x of 2t? X of 2t is nothing but our y of t. So I have to draw the value of this y of t. I have to draw for this y of t. Y of t. So how will you draw? First, for t equal to 0, y of t value, that is y of 0 equal to 2. That is t equal to 0, y of 0 is this one, x of 2t. This is x of 2t. So x of 2t is 2. So y of t or x of 2t both are same. That value is equal to 2. So 1, 2. Keep this point. Next, for t equal to 1. For t equal to 1. So this is 0. I had taken as this one. T equal to 1. T equal to 1. So at the point, what is y of t? Y of 1. Y of 1 is nothing but y of t equal to x of 2t. It is x of 2 into 1. That is x of 2. So at t equal to 1, the x of 2t value will be equal to 2. The x of 2t value will be equal to 2. See this? 2. That is at t equals 0. That is y of 0 or x of 2t value is 2. The same way at t equal to 1, y of t, that is x of 2t value is equal to 2. At t equal to, this is 1, at t equal to 2, y of 2, that is x of 4, and that is x of 2t. X of 2t value equal to 0. So 0 means somewhere. So this is 0. There is no need for it. So everything is zeros there. So there is no need to write. Now join this one. Join this one. See. For these values, how can I get? So 0, I got 2. For 1, also I got 2. So this is the time scaled version of this x of t if the value of that a is equal to 2. A equal to 2. Now see, here the signal is compressed. Simply it is compressed by the factor a. If you observe that this is 2. It is compressed by the factor 2 because we are multiplying the t with 2. If the factor is a, then the signal will be compressed with that factor a. So simple logic. There is no need to do all this thing. The simple logic I will tell you. Whenever we want to get the time scaled version of x of t, only you have to do is you have to divide the scaling factor. This is the scaling factor. This a is scaling factor. Divide the scaling factor at every instant of time. Okay, at every instant of time. At every instant of time in the signal, divide that each and every instant by the scaling factor a. So in the given signal, this is the given signal. So here at every instant of time, this signal at every instant of time, that is at 0, divide with the scaling factor 2. Whatever the factor is. In this example, the scaling factor is 2. If it is a, divide by a. And this is the time instant, divide by a. This is the time instant, divide by. This is the time, divide. So at each and every time instant should be divided by that scaling factor to get the time scaled version of the given signal. That is a simple logic. Time scaled version of the given signal. So the only thing. So for this example, there is no need to write all these things. So for same example, I want to get the time scaled version. Here as the value of a is 2, which is greater than 1, hence it is the time compression. So signal has to compress. How can I get? Simply by dividing every instant of time in the signal by scaling factor, that is by a. Here the value of that scaling factor or a is 2. So in my example, I have to divide every time instant with 2. So this should be divided with 2, and this should be divided with 2, and this should be divided with 2. So then what the values I will get? 0 by 2, 0, 1 by 2, 1 by 2. 1 by 2 is 0.5. So this is 0 and this is 1. Then 0.5 is somewhere like this. This is 0.5. And next 2 by 2 is 1. 2 by 2 is 1. See, 2 by 2 is 1. Clear? At this, the amplitude, because we are going for time scaling. We are going for time scaling. That is, the change is only with respect to time. There is no change in amplitude. So at 0.5, the amplitude is this one. At 1, the amplitude is this one. So simply, the amplitude is same. So 1, 2. So the amplitude is same. 0.5, 2, and 1 also 2. See, this is x of 2t. This is t and this value is, so both are same. See, observe this. These both are same. So the name need to do like this. So I explained this. This will be useful when you go for discrete time signal or for your better understanding. In discrete time signal also you can directly use this one. Use this one. So this is the better way to understand. So for you, there is no need to go like this. You can do like this directly. So simply divide every time instant in a signal by the scaling factor A. So here in my example, the scaling factor A value is 2. So I am dividing every time instant with 2. So 0 is divided by 2, then 0. 1 is divided by 2, that is 1 by 2, 0.5. And 2 is divided by 2, that is 1. So I have 0, 0.5, 1. So at 0.5, the value amplitude is 2. At 1 also the amplitude is 2 because there is no change in amplitude because it is time scaling. So there is the scaling factor will affect the time. So see, this is the signal, active signal. This is the time scale signal. That is, the signal is compressed with respect to time. So the time compression occurs here. So how it is compressed? It is compressed by the scaling factor. So here the scaling factor is 2. So it is compressed by a factor 2. So it is reduced by factor 2. Simple logic. Simple logic. Now, you can take another example. You can take another example. Okay. For a clear understanding, you can take another example. This is t and this is x of t. This is 1, this is 2, this is 1, this is 2, minus 1, minus 2. Okay, minus 1, minus 2. Now, here also I am taking a value as, take small a, the scaling factor is 2. Scaling factor is 2. And how can I get? And how can I get? Then how can I get x of 2t? X of 2t. I already explained you. Simple logic is divide each and every time instant by scaling factor. The scaling factor A is 2. So divide this with 2, this with 2, and this with 2, and this with 2. So minus 2, simple. Minus 2 divided by 2, that is minus 1. So minus 1 will be like this. Minus 1 divided by 2, that is minus 0.5. Minus 0.5. 1 divided by 2. 0.5. 2 by 2, 1. So for all the cases, the amplitude is 2. So 1, 2. See the signal. See the signal. See, this is a larger signal that is compressed. That is compressed by the factor 2. So if it is not 2, if it is 3, write down 3. If it is not 3, if it is 4, write down 4. So divide with that scaling factor. Are you clear? Clear with this? A signal is compressed. As a signal is compressed. So you can go for another example also. You can go for another example. You can go for any number of examples. 0, 1, 1, 2, 3, 4. Okay. This is x of t. This is x of t. Now what you have to find out? What you have to find out? Scaling factor. Again I am taking 2. So the a value is equal to 2. So how can I get the scaling factor? So I get x of 2t. This is t. This is x of 2t. X of 2t, how can I get? Simple, divide each and every one with that factor 2. So 0 by 2, 1 by 2, 2 by 2, 3 by 2, 4 by 2. 0 by 2. 0 by 2 is 0. The amplitude is also 0. Next, 1 by 2. 1 by 2 is 0.5. 1 by 2 is 0.5. So, actually, this is 1, this is 2. So, 0.5 is like this. So, at 0.5, what is the amplitude? Amplitude is 2. Amplitude is 2. So, take the amplitude 1, 2. 0.5, the amplitude is 2. This one. Okay. That is the waveform goes like this. After 0.5. After 0.5. Next, 2 by 2. 2 by 2 is 1. Take this as 1. At 1, the amplitude is 2 again. The amplitude is 2. Next, after 3 by 2. What is 3 by 2? 1.5. So, this is 1.5. There also, the amplitude is 2. So, 2. Finally, 4 by 2. 4 by 2 is nothing but 2. So, 2. Say, there the amplitude is, at this point, x of t value is 0. At this point, 0. So, it has only value of this one up to 1.5. Up to 1.5 is this one. So, up to 1.5. Up to 1.5. After 1.5, it starts decreasing. It starts decreasing. So, the shape is same. Clear? See, these are both same, but it is compressed in time. So, this is simpler. This is compressed in the sign. That is, this is compressed by a factor 2. So, this is simply time scaling. Time scaling. For A, the mod A is greater than 1. Mod A is greater than 1. Now, we will see for time expansion. Time expansion. That is, mod A value is less than 1. Mod A value is less than 1. That is, we can take 0.2, 0.3, 0.4, 0.5, whatever it may be. So, any one of them. So, there I can take that as 0.5 because 0.5 is nothing but 1 by 2. So, there I will take 1 by 2 for this. So, next I will explain you time expansion. Okay, time expansion. Up to now, you saw the time compression. Up to now, you saw the time compression. From now, we'll see the time expansion. Okay.